Blockchains are deterministic, but the real world isn't. The wall every smart contract developer eventually hits, that they realize that a smart contract knows everything inside it, that is every balance, every state change, and the full history of its own logic. But the moment you need something from outside, for example, the current price of Bitcoin, whether a real world event has happened or not, what an API actually record, the contract becomes blind. The reason is because that information doesn't exist on chain, and so the contract cannot just go and fetch it. So the common standard phase is to push it from outside. You run a service that watches for those facts and writes them into the chain. We call them oracles. It works, but you've made a trade. The contract is trusted right up until the moment it has to act on data from that one external service. That service is now the single point the entire trustless system has to take on faith. Sonia's answer is different. It's called Sonia's agent. So instead of feeding facts in from the outside, the contract calls an agent, like it posts a request, fetch this URL, give me that number, and then it keeps running. Then a subcommittee of validators each run that same request independently. They compare their answers, and when they're angry, the answer comes back in an unchanged state. Not one server pushing data in, a committee reaching consensus of what the real world accepts. That request consensus comeback loop is the Sonia agent primitive. Everything I'm building in this series rolls on it. Today I'll show you exactly how it works by building a RiskDex. A RiskDex is a contract that sells protection against a Bitcoin drop and pays out automatically when a Sonia agent confirms the price has crossed the threshold. We'll start with the Sonia Foundry starter. Before I write anything, let me tell you what it does, right? So in plain words, no code, right? Because we start writing code before we get into the this thing, it can get murky, right? The way RiskDex works is it, the owner of the desk writes a policy. That means they've created a policy. So the policy could be something like, if Bitcoin falls below $19,000 per Friday, I'll pay out 0.2 STT, right? So the owner puts up that payout and set a premium as the price of protection. Then a buyer can come along, right? They like the deal, they'll pay for the premium. Now they are covered. Then if Friday comes, right, we have to settle. And the question is, did Bitcoin actually drop below $90,000, right? And normal smart contracts, right, cannot see Bitcoin price. Often they have to use Oracle, but with Sonia again they don't have to do that, and they have to rely on Oracle. And then but the data is pushed out from outside through an Oracle, right? It is not the contract requesting for that particular information. The contract can't see Bitcoin price. It can't even make an API call. So it asks, it fires a request to a Sonia agent, right? This whole platform is what is encapsulating all those things together, right? It says, fetch this URL, read this feed, give me that number. The agent answers come back into the contract as a state. We compare it to the threshold, and if it is triggered, the buyer gets paid automatically. No one pushing a button. All of this is happening in a decentralized form. That's the whole journey, right? And it's exactly the life cycle on the screen. Created, quoted, is purchased, resolution is requested, is resolved, so either fails or it succeeds. And then if it succeeds, they are paid. Every box is a real status the contract has to move through. It's a policy, right? By the end of this episode, you'll have built this contract, we'll take it on a spin and set up some few tests to ensure that it works. I'm going to clone this. I'm going to clone a Sonia startup project, right, for Foundry. I use Foundry. I'm going to clone it into a directory called Nev. I've never used the name. I'm going to give the RiskDex because the RiskDex is just a foundational part to explain what's going to happen. I mean, to explain to an agent, because we're going to build more on it, right? First one is just a simple API call, and then we're going to build more on it using different agents available and different methods, right? Just to show the power and the capability some agents give us in a smart contract. I'm going to just run that. So it's getting cloned. That's so simple. I'm going to walk you through everything, right? So the reason I did not start from a blank forging it, right? I cloned this Sonia Foundry starter is because he already encodes things about this chain. Otherwise, I have to relearn by hand, right? One of them is the event Paris pin, right? And the legacy deploy script, all right? So it's public, right? It's in the description, so you can follow along from the exact thing, like, right? Begin where the chain quirks have already been solved, right? So you're not fighting setups, you're just going directly into the code. And this session stays exactly on the identification, so instead of setup, right? Inside of the nav directory. So it says everything is fine. Okay. But then it gives us a warning on the environmental file. It says missing copy environmental file. So okay, so it copies the example environmental. Right. So this whole file is about 160 lines. Okay, and it's kind of. Let me just collapse it. Right. The three interfaces, right? We have iAgent requester, iJSON API agent, and iAgent requester, and kind of interesting names, right? iAgent requester is the platform. I called create request on it. iJSON API agent is the agent I'm pointing at. iAgent request handler is me, right? The shape the platform expects when it calls me back. And one thing to internalize, right? So I'm going to expand into this, right? You see handle response on it, right? You see, this just we'll explain it, right? One thing to internalize about these types, right, is that they are not just suggestions, right? If you miss it, right, the platform encodes the answer with these exact structs, right? The 6-field response, this one, right? So you can see 1, 2, 3, 4, 5, 6, right? If I tell results, I'll explain it later, right? The 5-value the 5-value response status. You can see it here, non-pending. This is just to map out an asynchronous call. The 15-field request struct. So this one's quite huge, right? We're going to explain all of this later as we go on in the episode, right? So Mandler has to decode with the same one, right? If you get a field wrong and the callback can't read the particular value, it reverts on the code, right? That's before your code even runs, right? So it just fails. That's in one word, it just fails, right? So that's how we'll copy them out of the starter instead of handwriting them, because they just work as they are, right? They're correct. We don't want to touch them. So I'm going to just open my folder. I'm going to create risk.so, right? And what I will do is I'll open it on the side, right? So you have it here, and then I'll have agents.so we can see them side by side. What I'll just do, so I'll just copy everything out. I mean, from this end, I'll copy it down to the iAgent requested, so to line 72. I'll paste it in my risk.so because these are the type I have to follow, right? So if you don't want to make mistake trying to write it out by hand, it's as simple as that. You can ask your agent to copy it out for you, right? And then, all right, you will see that we've not copied this one. We'll do that later, right? There's a reason why we'll do that. It's just an extension of this particular interface. These are main contract. These are just the types and interface that we have to that we have to fulfill that we are copying, and we don't want to make mistakes copying them by hand, right? Now, these are the platform inclined thing. We're going to now go to write our own contract, right? We're going to define our own contract. Before we continue, I think we should first delete our counter.so. Just an example. We'll go to test, so we should delete that too. I should just delete that. It's just an example. Our script, we should delete our script, but we'll look into that later. So let's work on our own platform types. What I can do, I can just do this. Just do so. Text type is just what kind of fact this desk sets. It could be a crypto desk, it could be a weather desk, or a news and sports desk, right? We're building the crypto desk today, right? So resolution status at the bottom mirrors the agent's own status code, right? It's just non-pending success field and timeout. So it's just mirroring the standard response status here. And the reason why we're doing this is because we want to store it on the receipt, so we keep our own record of how things went, right? How did the call go and all that, right? So that's just like a bookkeeping case, right? Policy status, right, is the old policy which I showed you earlier in the diagram, right, where like person puts up a risk, right, a policy, right, anybody and is interested gets quoted, they purchase it, right, and then the resolution is resolved, either paid or it fails or it's cancelled, right, and then or the whole system just fails entirely, right? A policy, right, as we've said, a policy can get created, then it gets quoted, it's purchased by anyone who's interested, then the resolution is requested at a particular set date or by a particular event, then it gets resolved and then it gets paid. So that's the straight line, the same part you just saw in the diagram, right, earlier, top to bottom. Cancel or fail are just the two ways it can fail or fall off the line. Every value here is a box, and moving a policy from one box to the next is basically a contract or two structs we hold the data. Policy is everything we need to know about one deal. The field that matters are the buyer. Buyer is who is covered. Source URL and source selector are the URL the agent fetches and the exact field it reads out the response for. For us, the CoinGecko price endpoint and the path Bitcoin.USDC. Threshold is a line that designed to pay out $90,000 stored at 8 decimal, so it lines up with the scale the agent and back. Premium is what the buyer pays. Payout is what they collect. Status is the enum we created earlier, right? This one. and say it here, place status, right? Observe value and request ID start empty, and then they get fed in by the agent's call. Observe value is a number that comes back. Request ID links this policy to the request we made for it. Let's move on to receipt. Request receipt is a record of a single agent's call. What we asked, what came back, whether it triggered, what we paid. Today, we just write it and move on. But this is the proof of what the agent said and what the contract did about it. And in episode 3, this receipt becomes the thing the user actually opens. This block is all plumbing, right? No logic here, right? So just declaring everything, the functions we need, right? The constants up top, right? The first one is the JSON API agent ID, right? It's the registry ID of the exact agent we are calling. That's Sonia's agent API agent. Then subcommittee size 3, right? That's the size of the committee that we agree, right? We see from that particular listening, we had 3. That means 3 decentralized nodes are going together on a particular response before it becomes a consensus. And the price per agent, right? We decide what the request costs and we'll use them in the middle. Platform and owner are mutable, right? We want to set it once in the constructor and never again. Right? Platform is the agent requester we send requests to. Owner is whoever deployed the desk, the only address allowed to write policies, right? One is policies by ID, and that is receipt by request ID. And then the middle one is the pending request, right? It maps a request ID back to the policy it belongs, right? As a thread, the callback pulls on. When an answer comes, all it carries is a request ID. And this is how the contract figure out which policy that answer is for. Created, right? There's policy created, quoted, policy purchased. You can see that it matches exactly with the different status of the policy, right? So they are self-narrative, right? Every change emits on. Your errors are just the name list of ways it can say no, right? And I'll just leave a receive function here, right? It's just a way to it's just a way to let the desk actually hold the STT, right? Which is it has to, because it's the one on the hook for the payout. So the shape exists, nothing does anything yet. Where every piece the function need is now declared. Oh, okay. One more thing, right? I have to expand on this. The only owner, right, ensures that only the message sender, if it's not the owner, right, it should revert to that particular error. It should revert to that particular error. It should revert. This just enforces that the message sender is the owner, right? So, or else it's just revert with this assertion, only owner. Just as simple as that. That's all. So we'll start going into the logic of the OSEP. I think we may have 4 functions, right? I'm going to set up a policy. What it does is load a policy by ID, right, and revert everything there. Everything that touches a policy goes through this. So does this exist check live in exactly one place, right? The required JSON API deposit, right, is just what a realization will cost, right? I mean, it's the platform floor plus a reward for each agent. So it's a committee, and this, right? Why it's floor plus reward here is kind of a gotcha. Okay, and I'll explain it the moment we have to spend the money, right? Let me just create some few getters. Policy and get receipts are just really so the text and the dashboard can stay inside of the contract. We forgot to put in the constructor that I was trying to set up the O variables. And so there's a constructor, and I'll just start plumbing right away. Right, first create policy is the owner writing the do, and the arguments basically are the policy kind of desk, the title, the source URL, and the field the agent to read, the threshold that they decide the payout, and the payout amount, right, and when exactly it expires. We refuse it outright if the expiry date is already passed. No point creating a policy that's an arrival. Otherwise, we store it and then stamp it created. That is the first box on the diagram. The policy exists now, but nobody has priced it and nobody has bought it. Quote policy is the owner putting a price on it. One number, one premium, which is what the buyer pays for the coverage. The sellers move from created to quoted. That's the whole function. The deal is now on the shelf with a price tag. Purchase policy is the buyer stepping in and is payable. They send the premium with a call. We check for 4 things. The policy is actually quoted. It hasn't expired. They paid at least the premium. This is the one people skip. The desk is already holding enough to cover the payout it's promising. Selling protections you can't pay out is how you end up with an insolvent desk. You just don't let the purchase through unless the money is there. All 4 hold, we record the buyer and we move it to purchased. Now, someone is covered, and the only open question left is what Bitcoin actually did. That's the agent's call, and that's the next 2 functions. All right, so this is the request reservation function, right? What we've done, we fetched the policy, we check the policy status. If it's not purchased, right, we revert it. We check for deposit, right? If it's underfunded, we revert the call too, and then we build up a payload for the request resolution. I mean, we've done all our sessions and we're sure that it works. So we're going to start working on the logic, the main logic, right? We've done, so this is just the JSON API, the selector, the source URL, and then selector particularly, and then the value we're expecting, which is 8 value, which we already pointed out earlier when we said the CoinGecko API, right? It has a 8 decimal value, right? And then now, so let's look at what I'm under the platform, because this is the key part, not just the payload alone. Right? If you see, we have a JSON API agent. Right? If you see, so we have a JSON API agent. Right? This is which agent to ask, right? So now let's look at what I under the platform. Right? See, this is which agent to ask, right? That's what JSON API agent is for, right? That's the registry ID of the Somnia's JSON API agent, right? And then I have my own address, and then the selector of the function I want to call back. You can see there is no alight in there. That's because the platform doesn't recognize it. We're here to build this particular part out, right? I'm not waiting for a return value. If you see this whole thing, I'm not waiting for it. I just proceed. I just continue on, right? I'm not waiting for so it's a fire and forget mechanism, and that's on purpose, right? This undo selector, this undo response to selector, right? It points out the function which we have not written out yet, that is what the platform is going to call back into our own contract, right? So that's the other half of the loop. We'll write it next, and then we'll compile the pair. Before we do that, right? The undo response is it's part of the function, the whole system is an interface, and we have to fulfill it. So if we go back up a little bit, we will see here, right? Let me just collapse it. Right, see, so we have this I request handler interface. Okay, so it's an interface that we have to fulfill. If you don't fulfill it, when the callback is made and we do not fulfill it, we made any single mistake, your system is going to get reverted. It's not going to function well. It's not going to be a closed loop, right? So we have to ensure that. So we're going to extend the interface, and boom, right? So this allows to call the particular function and explain it out. It's an interface. So the interface is just a contract that you have to fulfill. That's what we're doing. So our contract RiskDesk is now implements this particular thing. It usually extends it. This function, right, undo response is where a Somnia agent answer becomes a contract state. Off chain, a validator read the price of Bitcoin. On chain, that number becomes a variable that I can branch on. That's Somnia agent called end to end in one function. So I'm going to go back there, right? So let's look into it, right? Two lines protect this whole thing because right, I'm going to explain it, right? First is that only the platform may call it back. So you can see it if message in the address platform revert, that means only the platform can call it back. And the response is a public function. Without that check, anyone anywhere from any place can call it and hand our contract a fake Bitcoin price, then walk off with the payouts. The only voice this contract trusts about reality is the platform. The second thing we did, which we see here, right, is I delay the pending request before I send any money, right? That's check effect interactions. If I paid out first and deleted after, a malicious buyer contract could re-enter and the response during the transfer and get paid twice. So delete before transfer closes that door. Two lines, one stops someone faking reality, the other stops a re-entrant callback from draining the desk.